So the goal of this video is to give you a kind of overview of the entire quarter, and you get a picture of what you're going to be doing. And again, the whole course is working towards having you build an op-amp. And if you remember op-amps, they're differential input, differential output voltage amplifiers. They have it for an ideal op-amp, which you used in 211. And I really like to ask this kind of as a question in class, but I think this time I'm going to just give you the answers and hope they remind you. There's three things you look for in an ideal op-amp. So an infinite Rin, zero ohm Rout, and a gain equal to infinity. So some of these actually mean something else. They're kind of shorthand for something else. And for example, that's not what I wanted to do. For example, an infinite Rin means that the no current goes into inputs. So when somebody says, oh, my circuit has an infinite Rin, all that means, remember, current is the most important thing for circuits. It's really all about what's happening to the current. When you talk about voltage, it's how much current wants to go from one place to another. Resistance is how hard it is for a current or electrons to go from one place to another. Capacitance is how much charge you need to get a voltage up to a certain level. Inductance, a magnetic field caused by a current. So everything, if you get a new metric on a circuit, I don't know if this is actually true, but I'm saying it anyways. Think about what that means for current. Because all the descriptors that you have, voltage, inductance, capacitance, all those have to do with current. So when you're looking at an infinite Rin, that just means no current goes into a circuit. And if you, we'll go with that later. Okay. Rout equals 0 means it can supply. So if this circuit right here, if you say this has an Rout of 0 ohms, what that means is the circuit can supply infinite current without changing Vout. So if you connect this circuit to some other circuit, if you're connecting that circuit to some other circuit, and this other circuit needs current to run, if you have a low Rout, that means it can supply current to the next circuit without it messing up its Rout. And the way you can think about that is, let's say you have, I'm going to model this strangely, but let's say you have this. This is your fake circuit. Okay, if you connect that up to some other circuit that doesn't pull any current, if it doesn't pull any current, if I equals 0 here, then this voltage will equal your supply voltage. And I'd use this symbol as a supply voltage. So if there's no current going into your next circuit, that means no current is going through the resistor. That means there's no voltage drop across the resistor. This side's anchored at VDD. That means this side will also be VDD. Okay. But if this is a big resistance, and let's say the current into your next circuit is not 0, now you're going to have a big voltage drop across here, and you'll be way far from VDD. You'll be VDD minus whatever that current is times your R big. And if you were trying to get VDD on your output here, it's not going to be VDD anymore. So when you think of a R out equals 0, that's where this is not big anymore. Now it's R small. Let's say this is 1 ohm. Let's change this. Instead of R big, let's make it R small. It's 0 ohms. R out equals 0 ohms. That's a small resistance. Let's say that's 1 ohm. You'd have to have a lot of current going through it. You know, if you had like a mega ohm resistor and you had 1 milliamp going through it, then you've got a volt. Did I do my math right? If you had a 1 ohm resistor and you had a milliamp going through it, you had a millivolt drop across there. So this would only be off of VDD by a millivolt. So what you're saying when you say it has a big R out or a small R out, all you're saying is that if I pull current off the output of my amplifier and it changes the voltage, that means it has a big R out. If I pull current out of the output of my amplifier and the voltage doesn't change, that means you have a low R out, and that's a good op amp. So that's that. Gain equals infinity. And this isn't, there's a number of different ways to build operational amplifiers. And we're going to build this kind of traditional 2-input amplifier. So in our case, when you say gain equals infinity, that means VI plus equals VI minus. These two are saying the same thing. Okay, so and that will the V out of your op amp, that equals your VI plus minus your VI minus times the gain of your amplifier. And you can see that if the gain is infinite, any difference between these two will just shoot V out up to infinity or down to minus infinity, and then the math doesn't work. So you have to pretty much assume that these are equal if you have a big gain when you're doing the math for these things. So saying the gain is infinite, what you're saying is you're just telling whoever's using that amplifier that your VI plus and your VI minus are going to be pretty close if you use feedback.